evaluate the limit if it exists, and the limit is as x approaches -1, 2x squared plus 3x plus 1 over x squared minus 2x minus 3. If I plug -1 directly in place of x, then I end up with 0 in the denominator, and that's going to be a problem. So I'm going to use a fact about limits that says that if f of x is equal to g of x, except at x equals a, then the limit as x approaches a of f of x is equal to the limit as x approaches a of g of x. We actually saw this fact in a previous video. We looked at the function x squared minus 2x minus 15 over x minus 5. We saw we could divide out a factor, and the limit we ended up with, after dividing out the factor, we had, f of x is equal to x plus 3 as long as x didn't equal 5. And the limit we ended up with was the same as the limit we got for g of x equals x plus 3, right? So the bottom line here is that if I can eliminate a problem value, or a problem factor, I should say, then substitute, then that's exactly what I'm going to do. So here we're going to say this is the limit as x approaches -1. The numerator factors into 2x plus 1 times x plus 1. The denominator factors into x minus 3 times x plus 1. The x plus 1's divide out. This then equals the limit as x approaches -1 of 2x plus 1 over x minus 3. At this point, what I can do is I can take -1 and put it in place of x in the numerator. I can put it in place of x in the denominator. And now we're relying on all those limit laws that say the limit of the quotient is a quotient of the limits, except we're not going to write all that out. We're just going to say in the numerator, 2 times -1 plus 1 is -1. And in the denominator, -1 minus 3 is -4. So this limit turns out to be 1/4. We're going to continue on, and this time our expression is the limit as u approaches 2 of, numerator is the square root of 4u plus 1 minus 3, and the denominator is u minus 2. We're going to proceed by rationalizing the numerator. But before I get to that, that's quite a process, right? So how do I know that I need to do that? Well, if I were to directly substitute u equals 2 into the denominator, I get a 0. And if I were to substitute u equals 2 into the numerator, you can see I will also get 0. So I'm going to end up with 0 over 0. When that happens, that's when I need to use some algebraic manipulation to simplify the expression. Looking back at our previous example, I didn't do that, and I should have. If we were to have substituted x equals -1 in place of x in both the numerator and denominator, this factor tells me it would have zeroed out. But if you do that up here, you'll see that you get 0 in the numerator. So 0 over 0 tells me do some algebra. What if it was something else that's not 0 over 0? That's something for another day. In order to rationalize the numerator here, I'm going to multiply by the conjugate of the numerator. So the square root of 4u plus 1 doesn't change. 3 doesn't change. What does change is the sign that's between the two terms. So I'm going to multiply by the square root of 4u plus 1 plus 3 over itself. I'm going to be left with the limit as u approaches 2. I have to write down limit every time, or every step, until I finally substitute the u, and we'll see when that happens. But until that happens, I have to write down this limit every single time. It's a lot of notation, but you get used to it. Multiplying the two conjugates in the numerator, I'm going to get the square of the first term, so 4u plus 1, minus the square of the last term, so 9. And you can see that the inner and outer terms will subtract out. That's why we're using the conjugate in the first place. For the denominator, I'm going to keep everything factored. So u minus 2, and then I have the square root of 4u plus 1 plus 3 as a separate factor. And I see this is going to be the limit as u approaches 2 of, in the numerator, 4u minus 8. In the denominator, that u minus 2 times the square root of 4u plus 1 plus 3. Now, as a little note to myself, I see I can factor the 4 out of the numerator, and I'm left with u minus 2. And look at that, the u minus 2 divides out. So the thing that's making the denominator equal to 0 divides out. That's what we're looking for when we are working with these. So I end up with the limit as u approaches 2 of 4 over the square root of 4u plus 1 plus 3. Basically, as long as I'm still writing u in the expression that I'm finding the limit of, I'm still going to write down the limit as u approaches 2. At this point, though, I'm going to substitute 2 in place of u. That's what it'll look like actually to take the limit. After reducing, you'll see that this limit is 2/3.